Hi students, we are discussing friction. So in friction I discussed laws of friction, then the friction problems based on horizontal motion and vertical motion, vertical surface on a horizontal surface and an inclined surface. Then I explained circular motion, okay, dynamics of circular motion. So we discussed a few applications, okay. Based on that, now we are going to do some more problems based on friction and overall problems in laws of motion. I will discuss in today's class few problems regarding laws of motion including friction, okay. You take this problem. So this is a figure, shows that there is a belt. On the belt man is moving. So this is a belt on which the rolls or the wheels. These are the two wheels on which belt moves. Okay, a man standing on the belt. Okay, the figure shows a man standing on a stationary stationary with respect to horizontal conveyor belt. What is this? Horizontal conveyor belt. Conveyor belt which moves horizontally. Its acceleration of the conveyor belt is 1 meter second to the power minus 2. So acceleration of the conveyor belt moving horizontally. Acceleration of the conveyor belt moving horizontally is 1 meter second to the power minus 2. Okay. What is the net force on the man? So if the coefficient of friction between man and the shoes belt is coefficient of friction. So coefficient of friction between the man, shoe and belt is 0.22. 0.2. So what is the net force acting on the man? So we have find what is the net force and the man. What is the net force on the man? Okay, this is the first question. And up to what acceleration B? Up to what acceleration? Up to what acceleration of the belt? Man can continue to be stationary relative to belt. Okay. So this is question. Mass of the man mass is 65 kg. Okay. So this is the problem. Okay. How we can solve this problem? Okay. See, there is a conveyor belt. Okay. On this belt is moving. Let it be like this. So the belt is accelerating. Okay. And a man standing on the conveyor belt. With respect to belt, man is at rest, so he can able to withstand, because there is a friction between the man's shoe and the belt. That friction will provide the support. If there is no friction between the belt and the man, he will slips. Okay, he can't stand on the belt. So he will also move with respect to belt. So this friction will provide for the man. So coefficient of friction is given. Solution. Okay. So coefficient of friction is given as 0.2. Mass of the man is given as 65 kg. So this is given data. And acceleration of the belt is 1 meter second to the power minus 2. Now this person is in a accelerating frame, because this belt is accelerating with acceleration 1 meter second to the power minus 2. So that is, the person is on the accelerating frame. So he is in non-inertial frame, and the frictional force acting on the person between the shoe and the belt. Okay, these are the forces acting on the person in horizontal direction. Okay, so if I draw the FBD, so FBD of man, I will draw. Since the man is in a non-inertial frame, we have to consider pseudo force. So the pseudo force acts on the person opposite to the direction of accelerating frame. So this non-inertial frame acceleration is left to right. So the pseudo force acting on the person is right to left. How much it is? MA. That is the pseudo force acting on the person. Okay, and the frictional force acts opposite to that. So the frictional force is F, that is contact force, that is, it is given as mu mg. So these are the forces acting on the man. In vertical direction, the weight of the man balances with the normal reaction. Okay, so these two forces will balance. So you leave these two forces. You consider the forces only in horizontal direction in which motion occurs. So if this MA, so you find this, we want the net force acting on the person. You first find this magnitude of pseudo force. So what is the magnitude of pseudo force? Magnitude of pseudo force on the person. How much it is? MA. Okay, what is M? 65. What is A? 1. So that is 65 newtons. So magnitude of pseudo force acting on the person is 65 newtons. What is the magnitude of frictional force? So magnitude of frictional force. So limiting frictional force. Frictional force limiting value is F is equal to mu mg. Okay. So you find this value. So F is equal to mu mg. Okay, what is mu? Mu is 0.2, m is 65 kg, g let it be 10. So this is 0.2 into 10, 2 into 65, 130 newtons. Okay, so this is the limiting frictional force value. Okay, so this is the limiting frictional force acting on the person. It is acts tangentially between the shoe and the belt. So this friction can support the man without slipping, because the man pushes by this pseudo force towards left, that can withstand by this frictional force. Okay, so it does not exceed this value, so man is able to can withstand. If it exceeds this value, pseudo force value, limiting value, the man falls in this direction, so he will slips in the backward direction when this acceleration of the man acceleration of the belt exceeds. Okay, so at this instant that is the belt moving with an acceleration 1 meter second to the power minus 2, the net force acting on the person, net force on the person we want. So this is the question for answer A. So we want what is the net force on the man. So the net force on the man is, so these are the two forces, MA and F mu mg. That is, here this frictional force is a adjusting force. At this instant the frictional force is how much? It is 65 only. So frictional force, so I will write first this one, then I will write this one, because this is very important point. So before going to answer this, I want to state a frictional force. So frictional force, friction, I said it is a self-adjusting force. Friction is self-adjusting its force, self-adjusting both magnitude and direction. So self-adjusting. At this instant, frictional force is frictional force between man and man shoe and belt is 65 newtons only. It is equal to applied force. What is the applied force here? Applied force is pseudo force, that is 65 newtons. So this point is very important. So friction is a self-adjusting force. At that instant, the frictional force between the man and the shoe is not 130, it is 65 only. So it is equal to applied force, that is pseudo force. What is the applied force here on the man? Pseudo force. So we want net force. Since the person is at rest with respect to belt, the force acting on the man is 65 newtons. So the net force acting on the man is 65 newtons. So with respect to a stationary observer, okay. So the force acting on the man is, I will write answer for this question. So the answer for the first question is, I will write here. What is the net force acting on the man is, the answer is, for this answer is 65 newtons. Okay, this is the answer. Okay, now we have to answer for what acceleration of the belt the man can continues to be stationary relative to the belt. Okay, you have to answer this belt. Suppose if this friction is as the belt moving fast, speeding up, that means its acceleration goes on increasing. As acceleration increasing, the pseudo force acting on the person is also increases. If it exceeds this limiting frictional force value, man can fall down because the friction is not sufficient, can stand on this belt with respect to belt. That frictional force has a limiting value. Okay, so if it exceeds, that pseudo force exceeds this value, man will slips with respect to belt. Okay, then afterwards man continues to move with acceleration of the belt. So I want up to what acceleration belt man can, so I am going to equate this answer for this. So to answer this first one, second one, B, solution for B. So this pseudo force MA should be balances with the frictional force mu mg. Okay, so I will write man will be stationary relative to belt as long as pseudo force acting on him should be less than or equal to limiting frictional force value. Limiting frictional force. Okay, limiting frictional friction. Okay, pseudo force is MA should be less than or equal to limiting frictional force is mu mg. Okay, so the maximum acceleration is mu g. So what is mu? Mu is given as 0.2 into g, 10. So maximum acceleration is given by A max is equal to 2 meter second to the power minus 2. So if belt accelerating more than 2 meters per second to the power minus 2, man will slips from the belt. Okay, so he cannot stationary relative to the belt. He will be stationary relative to the belt. Okay, if it exceeds this value, so up to what acceleration of the belt man can continues to be stationary relative to the belt. Okay, so up to this acceleration. Okay, so man is stationary relative to the belt. So this is the maximum value. Okay, we take this. Take next problem. Okay, two bodies A and B of masses 5 kg and 10 kg. 10 kg. Okay, in contact with each other. In contact with each other. At rest on the table. At rest on the table as shown in the figure. On the table against a wall. On the table against a rigid wall. Okay, so there is a diagram shown. Coefficient of friction between the bodies, mu between the bodies and the table is 0.15. A force of 200 newtons. Is applied horizontally. to A. What are we have the following questions. A, the reaction of the partition. A, first question, the reaction of the partition. B, action reaction forces. Between A and B. What happens when the wall is removed? What happens when the wall is removed? removed. Question. Does answer to be change, answer to be change when the bodies are in motion. When the bodies are in motion. Okay. Ignore the difference between mu s and mu k. Okay. So that is the question. So there is a wall. So there are two blocks, A and B. So there are two blocks, A and B. This is A, this is B. A is 5 kg, B is 10 kg. So this is a rigid wall. This is a floor. A force 200 newtons is applied on it horizontally. So two bodies A and B of masses 5 and 10 kg are contact with each other at rest on a table against a rigid wall. Mu of the body is given. A force of 200 newtons is applied horizontally to A. So this is the external force is applied on A. Okay. Now what are the reaction of the partition? Okay. So this is the partition. What is the reactional force acting on this? So from Newton's third law, for every reaction there is an equal and opposite reaction. So that means if you push this block A with the 200 newtons and this 500 kg block, the 5 kg block pushes this man with the same force 200 newtons, and in turn this 5 kg block pushes this 10 kg block with a force 200 newtons. Okay, and this 10 kg block pushes this wall with 200 newtons. So the action reaction between the pairs between this partition 5 and 10 kgs is 200 newtons. So it will forms action reaction pair between A and B. So action is the force acting on A, force solution. So force exerted by A on B is F is equal to FAB is force exerted by A on B is 200 newtons. Okay, that is action. The force exerted by B on A is FBA. That is reaction. It is also 200 newtons. So if you push this block A with the force 200 newtons, since A and B both are at rest because it is pressing against a wall, so the 10 kg is also press the wall with the 200 newtons. The wall in turn exert 200 newtons on the 10 kg block. The 10 kg block in turn exert 200 newtons this 5 kg block. So the action reaction between A and B, this partition is it is force exerted by A on B is 200 newtons and the force exerted by B on A is 200 newtons. If you take this one as action, this one is reaction. So it will form action reaction pair. That we can also call it as contact forces. And between action reaction forces between, what happens when the wall is removed? So if this wall is removed suddenly, then these two blocks set into motion. So you have to draw FBD of FBD. If you these two blocks if wall is removed, what happens? If wall is removed, the blocks set into motion. Okay, since these two are contact with each other, we can take it as a single body. So what are the FBDs? If you take this one as net forces on the system is 200 newtons, the net mass is 5 plus 10, 15 kg. So I consider these two as a single block, and the net frictional force F1 plus F2. So what is F1 frictional force between 1 and 2? So I will draw this FBDs of 5 kg block. So 5 kg block, the applied force is 200 newtons. The frictional force acting between the ground and the 5 kg is F1. Let it be F1. What is F1 here? F1 is mu mg. So what is mu? Mu is 0.15. 0.15 into m, mass is 5, into g, let it be 10. So this is 1.5 into 5. So F1 is 7.5 newtons. Okay, this is 10. Okay, into 10. So F1 is 10 into 0.15 becomes 1.5. 1.5 into 5 becomes 7.5 newtons. So F1 is the frictional force between 5 kg mass and the floor that will act tangential to the surfaces in contact. Okay, of course there is another frictional force is acts also vertically also between these two blocks, which is balanced with its weight. So that's balanced with the normal reaction. Okay, so the vertical force acts between these two also, but these two, if you consider as a block, these two will get cancelled. The frictional force acting on between 5 and 10 in vertical direction will cancel with each other. Okay, but if you draw 5 kg mass, you have to show this one. So that is, then what if you draw FBD of 10 kg mass, FBD. So what is one more force is there, normal reaction. Okay, let it be M. So if walls are removed, if wall is removed, the block set into motion, let N be the normal reaction, L be the contact force between A and B. We don't know that contact force, let it be N. Okay, now this contact force N, the 10 kg block, if 5 kg block pushes the 10 kg block with a force N, the 10 kg block pushes 5 kg block with the same force N. That is action reaction pair. So if you draw 5 kg block FBD, the normal reaction, the force exerted by this 10 kg on 5 kg block is in this direction. Let it be N. Okay, that is the FBD of 5 kg block. If you want to draw FBD of 10 kg block, so what are the forces acting on that? So it is N only. That is opposed by frictional force. Let it be F2. So what is F2 here? F2 is equal to mu m2g. So what is mu? Mu is 0.15 into m 10 kg into g 10. So how much it is? F2 is, I will write here, 10.5 into 0.15. Sorry, this is 0.15. into 100. This is 15 newtons. Okay, so that is 15 newtons. The frictional force between ground and the 10 kg block is 15 newtons. That is opposed by this normal reaction. Okay, now I want this N here. So how do you get N? So this, if you treat this one as a single force, you have to F1 plus F2. You have to add F1 plus F2. What is F1? 7.5 newtons. What is F2? 15 newtons. So total is 15 plus 7.5. It will become 22.5. Okay, that is opposed by this applied force, 200 newtons. So what is acceleration of the system? So what is acceleration of the system? Acceleration of the system. That means if you consider A and B are together as a system, A, B, both, is acceleration of A and B. That is acceleration of AB. That is net force acting on it. F is 200 newtons. And the net frictional force F1 plus F2 by mass. Net mass is 15 kgs. So that is F is 200 newtons. Net frictional force is 22.5 by 15. Now you check this value. 200 minus 22.5. How much you got? I think we'll get 11.8. Okay. So what we want? 200 minus 22.5. That will give 177.5. 177.5 divided by 15. How much you got? Divided by 15. You will get nearly 11.8. Okay. So 11.8 meter second to the power minus 2. So this is the acceleration of the system when this wall is removed. Both blocks 5 and 10 kgs moved together with the common acceleration 11.8 meter second to the power minus 2. But we want does the answer for this B? What is the B? Reaction of the partition is 200 newtons. So the answer for the A is reaction of the partition A is 200 newtons. 200 newtons. Answer for A. Answer B is action reaction pair will changes. Okay. Answer, if the wall is removed, does answer to B will change? For that question answer is yes, it will change. Now how much that one we want? So for that we have to calculate the FBDs, to consider the FBDs. Okay. Now so both, let M be the normal reaction. We want this. Now I will consider this FBD or FBD of this. Okay, I will consider FBD. This is for answer B. Okay, so consider FBD of B. So what you will get? N minus F2 gives MA. I applied Newton's second law. So N is equal to N minus F2. F2 is how much? F2 is 15 newtons. 15 newtons. 15 newtons. M is 10 into A. It has acceleration 11.8. So what is M? 15 plus 15 plus, this is 11.8 into 10, 118. So this is 118 plus 15. How much? It is 118 plus 15. You have to get 133. Okay, 133 newtons. So So this is the normal reaction between 5 and 10. Okay. So when the bodies are in motion, what is the action reaction pair? 133 newtons. Okay. So I will write the answer here. So I got n value is 133 newtons. So the force exerted by A on B is FAB is 133 newtons, and force exerted by B on A is FBA is 133 newtons. So this is the answer if the wall is removed. So if the wall is removed, these two blocks will set into motion, that is they are also accelerated with 11.8 meters per second together, and this normal reaction, the force exerted by A and B is also changes. That will becomes 133 newtons. If the wall is fixed, its value is 200 newtons. See the difference. Okay, clear? Take this. A thin circular loop of radius r rotates about its vertical diameter, with an angular frequency omega. Show that a small bead on the wire loop remains on the wire loop remains at its lowest position, lowermost point for omega less than or equal to root gr. Okay, that we have to prove that. And what is the angle? What is the angle made by the radius vector joining the center joining the center to the bead, center to the bead with vertical down direction for omega is equal to root 2gr, root 2g by r. Okay, neglect friction, okay. So this is the problem. A thin circular loop of radius r rotates about a vertical diameter with its angular frequency omega. So there is a thin circular loop like this, okay, which is rotating about its vertical diameter with an angular frequency omega. So let it be a ring rotating like this. There is a bead on this ring, okay. Let m be the mass of the bead. So it remains at the lowermost position for omega is less than gr. What is the angle made by the radius vector joining the center of the bead with the vertical down direction for the omega? So what is vertical down direction? So we have to check this one. Now see, let us try to understand the given problem. So there is a vertical loop, okay. So that loop is rotating like this. So there is a bead at the bottom of this one. So when it is rotating, this bead is in a non-inertial frame. If m is mass of the bead and r is rotation, it will rotate in a vertical circle because of centrifugal force. It is in a non-inertial frame. Bead is in non-inertial frame of reference, which is rotating with an angular speed omega. So there will be centrifugal force, that is fictitious force, that is pseudo force acting on the bead. That pseudo force here, it is a fictitious, that is centrifugal force, which acts away from center of rotation. So this is the axis of rotation. So it will act away from the center. Suppose this is the position of the bead, which is at a height h. So it will be rotating like this along with the loop. So there will be, when it is here, what are the forces acting on it? So the normal reaction will act like this. Normal reaction between this wire and the bead. Suppose this is the position of the bead. So weight of the bead mg acts vertically downwards. So let it be, this normal reaction acts towards the center. So if you take this one as the center of this circle O, the normal reaction acts towards the center. So it will be, let it be M. So what is the M here? The force exerted by this wire, thin wire on the bead. Okay? So that let it be M. Solution. The force exerted by the wire on the bead is normal reaction. Let it be N. Force exerted by the wire on the bead is normal reaction. Let it be N. It will be towards the center. So this center makes an angle theta with vertical. So what are the forces acting on the bead? Let it be, this is the position of the bead. So it will rises along the wire Because of centrifugal force. Centrifugal force acts away from the center. So it tries to push the bead. A component of its centrifugal force, it tries to push the bead up the wire. As the speed increases, speed of rotation increases, it will be pushes more and more away from center because of centrifugal force. So the centrifugal force acting on the bead will be equal to magnitude of centripetal force, that is mr omega square, where r is radius of this rotation circle. Okay, radius of this circle, let it be small r. So this is, let it be capital R. So this O to center, radius of the loop will be capital R. So N will act in this direction towards the center O. Okay, so this is radius of the circular wire. Okay, now this is small r. So this bead rotates in a circular path of radius r. So when its weight of the bead balances with this component of normal reaction, that is, if this is theta, this one is also theta. Okay, so this component of normal reaction here is n, its component will becomes n cos theta, which is act vertically upwards. So this is the component of normal reaction acting on the bead vertically upwards. So how long it will rise? Until this weight of this bead balances with the component of normal reaction n cos theta vertically up. And the centrifugal force is, centripetal force is provided by this component of normal reaction, that is n sin theta. Okay, so n sin theta will provide centripetal force. So these are the FBDs of if you draw FBD of this bead, it will be the forces acting on this in this direction. Centrifugal force mr omega square, which is balanced with the n sin theta, and n cos theta balances with the mg. So when the bead is under equilibrium, so what are the forces acting on the bead? N sin theta balances with mr omega square, equation 1. Okay, and n cos theta balances with mg. Okay, so these are the forces acting on the bus. So what is the small r in this triangle? So in this triangle, this is capital R, this is theta, this is small r. So what is the sin theta? Sin theta is equal to small r by capital R. So small r is equal to capital R sin theta. So from this triangle, relation between small r and capital R is small r is equal to capital R sin theta. So I will write this equation once again. Okay, so n sin theta I am writing once again. N sin theta is equal to mr omega square. Instead of small r I am writing capital R sin theta, capital R sin theta into omega square, that is n sin theta. Okay, so sin theta get cancelled. So n is equal to mr omega square. Okay, this is the normal reaction. If you substitute this normal reaction omega value, so omega value you will get so mr omega square, but n cos theta is equal to mg. So but cos theta value will be less than, if you substitute n value here, mr omega square, cos theta is equal to mg by n. Okay, what is n? Mg by, instead of n I am writing mr omega square. Again m capital R omega square. So mm get cancelled. So you will get the cos theta value, but so this is equation 1. I take it as this is equation 1. This is equation 1. This I take it as equation 2. This I take it as equation 3. So from 2 and 3. From 2, 3. We have. So what we have, cos theta is equal to mg by n. 2 is here, 3 is here. From 2 and 3 I got cos theta value. So g by. But cos theta value should be less than or equal to 1. Maximum value of cos theta value is 1 only. So if you take 1 here, then omega square value, you bring this side 1. Here cos theta value less than or equal to 1. So this value will be less than or equal to 1. Omega square value should be less than or equal to gr. So omega will be, so what you will get, omega is equal to, from this omega is equal to less than or equal to root gr. Okay. So if omega will be less than or equal to root gr value, what happens? The wire, the small bead of the wire loop will remains at its lowest position for omega value less than, so this value should be greater, cos theta value. So it should be, if omega will be less than or equal to this. So here cos theta value should be less than or equal to 1. So this value will becomes less than or equal to 1. So this value g by r omega square will be less than or equal to 1. I will write here. Omega square I bring this side. So it will becomes g by r. So where I need a space to write. Okay. I will rub this one. So if omega value, so this cos theta value I will write here. Cos theta value is equal to, but cos theta is equal to, I will write here. Cos theta value will be less than or equal to 1 because its maximum value is 1. So g by r omega square maximum value, I will write this one. I will take this space. Okay. So since cos theta value less than or equal to 1, g by r omega square value should be less than or equal to 1. Okay. Less than or equal to 1. So g by r should be less than or equal to omega square value. So omega square value should be greater than or equal to omega value should be greater than or equal to gr. Okay. So if omega value greater than or equal to root gr, what happens? The bead makes an angle theta with the vertical. That means it will rise because of this centrifugal force when omega value exceeds this value. So what is the reverse to this? If omega value less than root gr, we can say that, so we can say that if omega less than bead value, bead will remains its at lowest position, that is at bottom here. That means this theta value becomes 0. So bead will be here only. If omega value less than root gr, if it exceeds this value, what happens? The bead makes an angle theta with vertical, so when it is under equilibrium. Okay. Now we want what is the angle made by the radius vector joining the center of the bead with vertical down for omega is equal to root g by r2. So I will take this one. Now I will substitute this omega value, okay, in these equations. So omega value I take it as, I want this theta value. Now in case B, this is the answer for B. When omega is equal to root 2g by r, okay, when omega is equal to root g by r, we want theta, okay. So now I substitute here omega value, okay. We have, I will write here, we have, so what we have cos theta is equal to mg g by r omega square from equation 2. This is R2. I will take, this is 3, this I take it as 4. This I take it as equation 4. So cos theta is equal to g by r omega square from equation 4. Okay. So I have this equation. I want theta when omega is equal to, so cos theta is equal to g by r omega square. When omega is equal to root, I will substitute this value 2g by r. Square root will gone. If you square this one, omega square, okay. So this g get cancelled, r get cancelled. So what you will get? Half. So cos theta is equal to half. So theta you will get as 60 degrees. Okay. So this is the answer for the question B. What is that there? If the speed of this wire loop, if it is omega is equal to root square root of 2g by r, this bead makes an angle 60 degrees with vertical. Okay, this is the answer. Clear? Take this.